Alright, so this section is about the binomial distribution, which should be kind of a review because we talked about it back in chapter 6. Towards the end, there was that really long video with Hawkeye and Trapper, where we wanted to see which was more likely for one of them to hit either Trapper hitting 7 of 9 greens or Hawkeye hitting 12 of 18 greens, and we gave the percentage of how often they do hit the greens on their first shot. And so we ended up finding out, comparing them and everything. So we talked about this back in a previous video, and so it's kind of a reinforcement of this because the next section deals with connects to this a little bit. So the binomial distribution is NCR, so combination with N and R. The probability to the R power minus 1 minus the probability to the N minus R power. Okay, so this finds the probability that an event occurs, assuming that it is evenly distributed across the with this the percentage. So, it's if it looks like that kind of, okay, or it could be shifted more, but it's kind of evenly distributed. So we're able to find it, and it's got a common divider and everything. So we're going to go through a couple examples of this. Or an example of this. So left-handedness. So for those of you that are left-handed, you'll probably get that picture. So about 11% of the population is left-handed, approximately, and so that's what we're going to use. We want to know the probability that if I have a class of 25 students, what is the probability that 3 of the students are left-handed, 2 to 4 of the students are left-handed, or 10 of the students are left-handed. So if I were just to pick, 25 random, if I were to pick 25 random students, put them into a class, I want to know what's the probability of them being 3 of them being left-handed, 2 to 4 being left-handed, or 10 of them being left-handed. Now, there is a chance that all of them are left-handed. There's also a chance that none of them are left-handed. But some of those chances are very small, especially the one where all of them are left-handed. That's a very small chance of that happening. And we'll see when we look at the 10 students. So 3 students left-handed. So our binomial distribution is NCR P to the R, and then it would be Q to the R, and then to the N minus R, and where Q is 1 minus P. And so we have 25 students, so that's going to be our N. Our R is 3, and then our P, 11% are left-handed, so it would be 0.11 to the third, 0.89 to the 25 minus 3. And so we see that's our setup, and then all you do from here is that you just multiply it through. Okay. So remember the combination for your calculator, the combination stuff is under math PRB. Math PRB, and it should be like number 3 under your calculator. So you type in 25 math PRB, 3, enter, and you should get about 2300. And then as you see, this is multiplied through, and then multiply them together, and we end up getting about 0.23577. Multiply it by 100, and that is our percentage. So there's a 23.5% that if I were to grab 25 students and put them in a classroom, that 3 of them would be left-handed. Now that's like me saying, if I made 100 groups of 25 students, I'd have about 23, 24 groups that would have 3 people left-handed. Exactly 3. Okay. So the next one is 4 to 2. So if you have a range of them, what you're going to do is you're going to add them together. So you would find the probability of 2, find the probability of 3, and find the probability of 4. Well, we've already found 3. That was 23.5. And so then we would find the probability of 2, which would be this setup, where instead of putting 3 as the R, we have 2, which then changes the powers. But the percentage is still the same, because it's still 11% chance that they're left-handed. Each individual is left-handed. So we'd multiply it through, and we get about 24.88. So as you see here, it's a little bit different than the 3. And then for the 4, we would do the same thing, but instead of the 2, we plug in a 4, multiply 3, blah, 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 and we end up getting about 16.03. So as you see, it drops off when you get to 4. And then to find the probability, we would add them all together. So as you see, we have the probability of 2, 3, 4, and you see how it kind of slowly falls. And as you keep getting more and more left-handeds in the class, it's going to get smaller and smaller. So when we add all these together, we end up getting about 64.5%. So groups of 25, students, if I were to get 3 groups of 25 students, possibly 2 of them will have between 2 to 4 left-handed people. Now, all 3 of them could, none of them could. I'm just saying there's a 64.5% chance that one of them could have 2 to 4 students. So again, we're talking about the chances of it occurring. So it's over a 50% chance. So now the next one, 10 students that are left-handed. So we'd set this one up. It would be 25 C10, 0.11 to the 10th, 0.89 to the 15th. And we would multiply it through, and as you see, we get a really small number. When we multiply that by 100, we end up getting about 0.01476%. Okay, so it's less than 1%. It's a tenth of a percent. Actually, it's 100th of a percent. Okay, so it's about 100th of a percent, which means basically, in other words, if we had 10,000 classes of 25 students, 10,000 classes of 25 students, there would only be 1, maybe 2 of them that would have 10 left-handed people in it. Maybe. Okay. And again, this is the probability that it does occur. Okay. I mean, you could have more, you could have none of them, but in theory, if you have 10,000 classes of 25 students, 1, maybe 2 of them would have 10 left-handed people in it. Okay. All right, your IRAT. So there's a multiple choice test. David can choose between answers A, B, C, or D. There are 15 questions on the test. Find the probability of the following. David gets a 80 on the test, gets a 66.7 on the test, or 2/3 on the test, and he gets none of the questions right. So what you have to do is you have to find what's the probability of him getting each question right. Okay, think how many answers are there possible, and only one of them are right. And then you have to find how many does he get right for each test. And then plug it into the binomial distribution, and then find them. And that is your IRAT for the binomial distribution.